Okay, so we left off putting these fractions in order, and I said maybe I confused you on this 3/5. Another way to look at 3/5 is your numerator, which is a 3. What if you doubled that? That would end up being a 6. So 3 over 6, if it was 3 over 6, that would be a half, but it's not 3 over 6, it's 3 over 5. And so that means that you would have, if it was 3/6, out of 6 pieces you got 3. Well, you don't have 6 pieces, you have 5 pieces. Remember, as your pieces, the less and less pieces you have, actually the bigger and bigger the pieces get. The smaller the denominator, the bigger your pieces. Like, would you rather have half of a pizza, or would you rather have an eighth of a pizza? You know, I'd rather have half of a pizza because my denominator is smaller. So anyway, if you didn't cross multiply those guys, that's just one other way to think about looking at your numerators and denominators. Alright, let's add, subtract fractions with like denominators. Piece of cake. If they're like denominators, you just leave them the same. So 6/5 plus 3/5 equals 9/5. Piece of cake. Now, we can't leave it as 9/5, so we got to change it to a mixed number. So you just ask yourself, how many times can 5 go into 9? 5 times 1. 5 times 1 is 5. How many more to get up to 9? 4. So that's your numerator. So 1 and 4/5. And that's it. You're done. 3/5 minus 2/5 equals 1/5. Super easy. What about this guy? 1 and 12/13 minus 2 and 11/13. Yeah, a little tougher. Now, first up, remember, we have to put the biggest whole number on top. It's got to be 2 and 11/13. You can't say 1 and 12/13 and put him up top, because you got to do the big number, the whole number first. So it's 2 and 11/13 minus 1 and 12/13. Now, everything's looking good until this. I can't take 12 from that 11. It's impossible to take a 12 from 11 until we get to negative numbers later. But anyways, in fractions, you can't take this 12/13 from 11/13. So what do? I cross out the 2. Here's my 2. I cross it out and make it a 1. And I'm going to bring over something. I don't want to just bring over, like, 1 and make that 12/13. No. I'm bringing over a whole number. So what's a whole number? When I'm looking with 13ths, it would be 13/13. So I'm bringing over 13/13. When I bring over 13/13, I have to add these two up, this 11 and 13, which ends up being 24. So I borrowed and made it 1 and 24/13. Sounds kind of weird. But now I can go ahead and subtract. 1 minus 1 is 0. I don't need to put it. 24 minus 12 is 12. And so it would be 12/13. All done. Alright. Equivalent fractions. 3/5. To get another fraction that's the same, just multiply it by any number. So I just picked 6. I was like, 3/5 times 6 equals 18/30. And I said, what about 9? I said, 27 over 45. It's that easy. I could even do 3 times 1,000,000 and get 3 million over 5 million. And, dude, look at this. That is awesome. Okay, go backwards by dividing. What about, like, they said, hey, you got 3 million over 5 millions. Give me another equivalent fraction to that. I could basically divide out millions, and I bring it right back to where I was. Here's probably more like an example you would get, 18 over 30. So I could divide both of those by 6, which brings me down to 3/5. Or what about 27 over 45? I could take 9s out of it, and so that would bring me down to 3/5. Cross multiplying, it's easier than Friday's spelling test. So if they had, here's fractions again, comparing 6/15 compared to 8/13. You're like, what? I don't know what that is. Just cross multiply. 15 times 8 equals a 120. 13 times 6 is a 78. When you look at the fractions, 6/15 and 8/13, you're like, that's kind of close. I'm not sure. But when you multiply them out, you're like, dude, that guy's way bigger. So, piece of cake there. Subtracting fractions, just like we did. 3 and 7/12 minus 2 and 5/12. That one's ready to go. So that's 1 and 2/12. The only thing you might want to do, well, you probably will need to do, is reduce. So you can divide the 2 and the 12 both by 2, and that gets you to 1/6. So it's 1 and 1/6. Over here, we got 13 and 7/12 minus 10 and 7/12. Oh, I put a 1, sorry. So that's going to be 3 and 6/12, but you see the 6 and the 12, you know they're even, so you could at least divide by a 2, and that's going to bring you down to, I just recopied the whole number stays the same. So I'm going to divide the fraction, 6 divided by 2, which is 3, and 12 divided by 2, which is 3. And so that would be 3 and 3/6, but I look at the 3 and I look at the 6, I'm like, I could still take 3's out of it. So 3 divided by 3 is 1, and then 6 divided by 3 is 2. Alright, so here's another one, kind of like that, the one where we had to borrow. We've got a 146 and 2/18 minus a 140 and 8/18. Can't do that. I'm going to borrow from this 145, bring over one whole. Now to bring over one whole, you look at the denominator, it's an 18. So I'm going to bring over 18/18, which ends up making it 20/18. And now I'm ready to subtract. 145 20/18 minus 140 8/18. And brings me down to 5 and 12/18. I know that these numbers are even, so at least I can divide it by 2, but could I go higher? I was like, yeah, there's a 6. I could divide it by 6. So 12 divided by 6 is 2. 18 divided by 6 is 3, so it's 5 and 2/3 eventually. If you did it divided by 2, you'd still get down to 5 and 2/3. It would just take you a little bit longer. Okay, what about adding all this stuff up? 70 and 5/10, 40, you get the idea. So just line all the stuff up and add it all up. You're like, woohoo, everything's looking good because they all have like denominators. You got a 147 and 16/10. That's the only problem. You got to fix this. So go 10 into 16, which is 1. So that's one whole number. 6 more to get there, so that's 6/10. Add that to your 147, and it brings you to a 148 and 6/10. I said fractions aren't the easiest, but you're awesome when you can figure them out. Alright, Chapter 8, multiplying fractions and whole numbers. 5 times 1/8 is the same as saying 1/8 plus 1/8 plus 1/8 plus 1/8 plus, you get the idea, equals 5/8. Makes sense. Think about regular multiplication. 5 times 7 is like saying 7 plus 7 plus 7 plus 7 plus 7. You get the idea? Or 5 plus 5 plus 5 equals 35. Right? So you're just doing the same thing. Okay? 18 times 2/9. You're just going to do the top number, 36, the numerator. 36/9, and then flip it around. 9 can go into 36 4 times. So it ends up being just a regular whole number 4. 25 times 4/8 would be 100/8. 8 goes into 100. I'm not going to walk it do everything, but it ends up being 12, which is 96. And then you'd have 4 more to get there, so 12 and 4/8. And here's long division if you wanted to do it that way. Alright, turn 7/8 into a whole number and a unit fraction. Okay, it said unit fraction. You need a unit fraction. So you need a 1 over something. So there's your unit fraction, the 1/8, because I'm never going to change that denominator. So I'm going to have a 1/8 times something. So I'm going to go 7 times 1/8. So that would be 7 as a whole number times 1/8, which gets me 7/8. Okay, the next one says turn into a whole number and a unit fraction. So we got 13/19. So 13 times 1/19. See it? So this would be 15 times 186. Okay, multiples of fractions. It's the same as like multiples of, what are multiples of 3? 3, 6, 9, 12, 15. You get the idea, right? Same thing here. You're just going to leave the denominator the same. So you're going to go multiples of 3/18 is 6, 9, 12, 15. See that? And then over the 18. So 6/18, 9/18, 12/18, 15/18. What would be next? 18/18, right? And then 21/18. Get the idea? Multiples of 5/14, same. 5/14, 10/14, 15/14. Get the idea? Forever and ever. Chapter 9, fractions, decimals, and percents. 0.90 is the same as saying 90/100. You could divide that by 10, and that brings you to 9/10, which is still equal to 90/100, which is your percent. That sounds kind of complicated, but it's not. Look, all right, 0.85 is the same as saying 85 over. Now this 85, here's a little trick. Look how many places there are. There's 1, 2. So you got 2 here. You're going to put 1, 2 right there. 2 zeros. There's for one of them. There's for the other. So that says 85 over 100. Or 85%. Check out this one. Let's say they gave you a fraction like 8, 5, 3, 2, 4, and they want you to turn it into a fraction. Do that trick that I've shown you over here. Count how many digits there are. 1, 2, 3, 4, 5. Put 5 zeros. 1, 2, 3, 4, 5 zeros. Boom. I'm almost done. That is 8, 5, 3, 2, 4. So that would be it. That's that is your fraction. That would be your fraction. Okay, you get it. Okay, tougher one. What about 8 tenths? Well, 8 tenths is the same as 0.8 or 80%. Think of it like a test. Like you took a 10-question test and you got 8 right. Wouldn't you get an 80%, right? So that's one way to think about it. I said, remember too that I could add a ton of zeros to a decimal or a fraction and it wouldn't change it. For example, let's say I had 8 tenths. I could put 8 tenths and then put a whole bunch of zeros as long as I matched up the 0. 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. As long as I matched up all the zeros, it's not going to change anything. All those zeros would end up reducing down to an 8 tenths. Okay, another idea with the zeros. Think of a regular number like 436. I could add a ton of zeros to the beginning of this 436. 0, 0, 0, 0, 0, right? But it's still 436. Well, fractions are the same, but in the opposite direction, since they're fractions of a whole. So if I took this 436, put 0.436, put a whole bunch of zeros on it, it's the exact same number. It doesn't do anything different. Okay, what about when comparing decimals? A lot of kids, when they first start, they look at this and they're like, ooh, that's definitely a bigger number. But think of it like ABC order. So compare this guy to this guy. 4 versus 4. Okay, they're tied. Next. 6 versus 8. Ooh, 8's bigger. If 8's bigger, that means he's eating it. So this 0.48 is actually bigger than that guy. Because if you did it like ABC order, that's it. It's over. 11 and 4 tenths is 11.4. Remember, there are no oneths place. Decimals start right away at the tenths. And so I just started one out, 11.4644, blah, blah, blah. To say this, go to the last place value, and then you would say the 100,000ths. So nothing super special there. Next, I said 11.5, what's the next number? Now 11.6 and then 11.7, but what if they gave you something else? If you wanted to go smaller units, you could go like 11.5 to 11.51. Now if you thought of it like money, then it's pretty easy. When you think of it like money, it's pretty easy. 11.5 is like $11.50. So $11.51 and then $11.52 and $11.53. And if you got rid of that little dollar sign, you're back into your decimals. So. Okay, 0.25 is like a quarter, 25 cents, or 25 out of 100, which is equal to 1/4, because I could divide both of those by 25, divide by 25, divide by 25, and that gets me down to 1/4. 14.60 is the same as saying 14 and 6 tenths. This is my tenths place. 125.7 is 125 and 7 tenths. And this is 125 and 7 hundredths. Notice the difference. This is pennies. This is dimes. Comparing decimals, fractions, and all this. So we got 6 tenths versus a 5 tenths or a 50 hundredths and 85%. First, change them. So the 6 tenths could be turned into 60%. Think of it like a test again. You took 10 and you got 6 right, so you got 60%. The 50 cents is done, it's 50%. The 85 would be 85%. Now it's a piece of cake. You just add them, or you just look at them. And so 50% would be there, there, there. And that's it. Almost done. Trying to go fast so we can fit it all in. What about this guy? We'll pick up on him next. Blah, blah, blah.